In note 6.5.2, example 6, we're asked to graph a transform cosecant function, which is y equals 3 cosecant of the quantity x minus pi minus 1. We'll begin sketching this graph by graphing the reciprocal function. So the reciprocal of this function is f of x equals 3 sine x minus pi minus 1. And once we graph the corresponding reciprocal function, it'll be easy to graph the cosecant function. So when graphing sine, the first thing we want to know is where is the axis of oscillation, or the midline, whichever one you want to call it. Here, this graph is shifted down 1, so we have minus 1 here. So that means that the axis of oscillation is going to be at y equals negative 1. And I'm going to put a scale on my y-axis, and I will draw in the axis of oscillation. So I'm going to do 1 square is 1 unit. And then I'm going to draw in the axis of oscillation at y equals negative 1. So y equals negative 1. This is the axis of oscillation. The next thing I want to do is figure out the amplitude. So the amplitude comes from the coefficient in front of sine. So in this case, we have 3. So the amplitude is going to be 3, which means from the axis of oscillation, the maximum will be going up 3 units. So from negative 1 up to 2, that will be where the maximum points occur for this sine function, and we'll go down 3. So negative 4 to my graph. And then we have y equals negative 4. Those will be where the minimum values go. The next thing we want to determine is the period. The period is determined by the value for b, in this case the coefficient of x. So b is 1. So the period for this function is 2 pi over b, which is 2 pi over 1, which is 2 pi. And when we sketch our graph, key points are going to occur every 1/4 period. So that's going to be 1/4 times 2 pi, which is pi over 2. And that will help us set the scale for the x-axis, which will make it easy for us to graph. And then we need a starting point. For sine, 1 point sufficient. Sine of x, the parent function starts at 0, 0 at the origin. And then let's list the transformations, or what we do to x and y. So in this case, x values, we have a translation actually right pi. So we're going to be adding pi, because we're going right pi, to our x values. So 0, 0 becomes pi 0. And y values are going to be multiplied by 3. And then we're going to subtract 1. Remember, we do things that multiply first, so dilations and reflections before translations. So we're going to multiply y times 3 times 3, because we have a vertical stretch by a factor of 3. And then we're going to subtract 1, because we're shifting this down 1. So pi 0 is going to become still pi 0, because 0 times 3 is still 0. And then we're going to subtract 1 from the y value. So pi negative 1 is going to be our starting point. I'm going to put a scale on the x-axis. So I'm going to do, because we said that key points were every pi over 2, I'm going to say that 2 squares are pi over 2. So I'm going to put pi over 2. I'm going to go over 2 more squares. That would be 2 pi over 2, which simplifies to pi. 2 more squares to the right would be 3 pi over 2. And then 2 more squares would be 4 pi over 2, which is 2 pi. Then 5 pi over 2. Then 6 pi over 2, which is 3 pi. And then I will put values in the negative direction. So negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And now we are ready to graph the sine function, the reciprocal function. So we had a starting point at pi negative 1. So I'm going to put that point on our graph. So pi negative 1. And now we need to determine, do we go up as we go from left to right or down as we go from left to right? So since we have no translation, no, I'm sorry, no reflections, so we'll go, graph will go up from pi negative 1. Okay, so we were at pi negative 1, then we'll be at, the next key point will be at 3 pi over 2, 2 at a maximum. Then at 2 pi, we'll be back at the midline. At 5 pi over 2, we'll be down at the minimum, which is negative 4. And at 3 pi, we'll be back at the midline. And we'll carry on in the negative direction. So pi over 2 would be down at negative 4. 0 is at negative 1. Negative pi over 2 is at 2. Negative pi is at back at the midline, negative 1. Negative 3 pi over 2 is at negative 4. And negative 2 pi is at negative 1. And now I can go ahead and sketch in my sine function and put in nice, smooth, rounded curves. I'm putting them in with dashed lines because we really want to graph the cosecant function. Put arrows at the end of the sine function because it continues. Now, to graph the cosecant, we know that vertical asymptotes occur whenever the sine function passes through its midline, not the x-axis. This is important. So we'll have vertical asymptotes when 3 sine x minus pi minus 1 crosses through its midline, which is at y equals 1. So I'm going to sketch in the vertical asymptote. So I have one here at x equals pi, another one at x equals 2 pi. So what's important here is where the sine function, the reciprocal function, crosses through its midline, not where it crosses through the x-axis. In the previous examples, there was no vertical shift, so the midline was the x-axis. Okay, so I put in vertical asymptotes, and now once we have the vertical asymptotes, we can go to the maxima and minimum points on the sine function and then graph the U-shaped curve. So we were at pi over 2, negative 4. That's going to become a relative maximum, relative maximum for the cosecant function. And then go ahead, put in the U-shaped curves in each of these intervals between the vertical asymptotes. And that is our cosecant function.